share screen. Okay. So, right, we're talking about this. So the first example, I really hate the way it puts that equals sign. Why does it do that? It's so annoying.
It does the line numbers if you have equal to, and I don't know why that default.
I know, but it's very insistent on putting it there. It's like hard not to put it there. Okay, so what is happening here? Here we have a mutable reference to, and the full path is like star bx. That gives us star to go through the and mute dot x, right? Okay, let's do the next example before we dig into this. And then your example was a mutable reference to, here we got star t dot s, sorry, t dot 0.
T dot 0, 0, dot 0. Oh no, yeah, that.
I think just that. And the difference is, was one other important detail. Right. So I have to be consistent. So the key point I'm trying to make here is that I distinguish these cases because in this first case, both cases have a mutable reference, or the mode of access is sort of mutable reference, right? But in this case, we have a deref of an ampersand mute in the place that's being accessed. But in this case, we don't. So I think in this case, the second case, sorry, what's this? So in the first case, we have a deref. What's this? In the place that is being accessed. And in the second case, we do not. And so my argument is basically that if we do have such a deref, we should not truncate, and we should keep the mutable reference mode. But if we do not have such a deref, we should truncate, and we should go to move mode. Right, so I think we expect, at least by the semantics of Rust today, this closure takes ownership of T and then mutates the thing that it owns. Whereas this closure in Rust today, it does take ownership of BX, but the thing that's getting mutated, it doesn't own, because it has to pass through a mutable reference to get there. And that's the difference, that in this closure, the data that's ultimately being accessed in Rust today is not owned by the closure. And just thinking of it more abstractly, the data that's ultimately being accessed is not owned by the variable that's being used to access it. That's really the case we're getting at. The data ultimately being, and that, I think that's the distinction I'm trying to make. And in the second case, the data being accessed is owned by the variable t. So the idea was that when we're accessing data that we don't own, or when we're accessing data through a variable that doesn't own it, we should borrow. And I think in those cases, you will not cause compilation errors. Does that make sense?
I feel like implementing this. It makes sense. I feel like implementing this would be annoying. And
Yeah, I kind of feel a bit lost about the global picture, and maybe we have a little time here. Maybe we want to spend a little time just like writing up the
yeah, I think we should do that as a group. I started writing it, and like I think it gets far more complicated than I thought it was going to get.
Okay.
Just because.
Yeah, it probably is complicated. So let's take a look. So we got, I mean, the way I see it is.
Yeah,
Go on.
To me, I think the most generic case would be if the thing doesn't contain derefs. It's a very simple situation there. And that is it's a move closure, or what's it called? Borrow immutably, mutably, or depending on if it's not a move closure and depending on how it gets used.
Yeah. So I think, well, before we go that deep though, the model I have in my mind is that you analyze a closure C and you get a set of mode place pairs that are accessed. Mode is and mute, or let's call it ref mute or move, I don't know, or by value.
Do we want to include unique immutable here, or is that part of ref mute?
Bother.
Or can
hey, let's just include it, but I don't think it makes much difference. And then closure mode is sort of ref or move.
Yeah.
And the output, yeah, so this is the input. And the output is basically mode place pairs that are actually captured. Minimal. So now let's see consideration. So first thing is, before we get into this stuff, there's already this minimization step that was going from like, if I access A.B and A.B.C, I need to take A.B with the mode that is the, actually this ordering is, this ordering's wrong, right? It should be probably like this.
Yeah. Yes. Yeah. Yeah, we can just say this is the strict, we got like, yeah, least to max, that works.
So
yes, I think the combination step is at the very end, and that we don't really, that we can just do later on. Like the the minimization step is a yes.
So let's do this.
So I have this.
If there are, for each two places like M1, P1, or yeah, okay, M2, P2, where P1 is a prefix of P2, we basically want to remove both places and add max M1, M2, P1. To describe it in this weird way. But this is sort of the formalism I have in my mind, that there's like a series of rounds where you take things out and you put things back in. And in the end, you get to a fixed point and you're happy.
Yes. Yeah. Either we can
Actually,
say applied until this cannot be applied, until the set has no P1, P2 says that P1 is a prefix of P2, or you start with an empty set and that like it comes to an implementation detail after that, how you make this fast. But
yeah,
the stopping point of this is no two entities and
right. Um, there's actually, I'm just remembering that there's a nice, I forget what it's called. I have to look it up, but there's a Prolog-like language that has this as its basic model, take things out and put them back in. And we could try to model it later.
data log.
And no, Datalog is different. I forget what it's called. Tuple space is one thing that works like this, but there's another one. Point being, if we get it properly done, it would actually be cool to try to specify it in that language and try it out and test it. I'll think of it later. So the next thing is, right, so we've got these rules around mutable references and moves. We have to take into account move mode now. So how does move mode play in?
Wait, move mode or closure mode?
Sorry, I mean
You mean
closure mode.
right?
Yeah. Let's call this access mode. And we'll call it closure mode. I mean closure mode. Where to move. So I'm contending that I think move closures might be a first pass. I'm trying to remember how we had, I know we went through this and I don't remember where we landed, but I'm thinking of it now as move closures are a first pass that mutates like something like if this is a move closure,
Mhm.
then it kind of goes for each mode place in C.
Mhm.
And we're going to map it basically. Let's call it map each mode place in C. So we say, basically, if the place contains a deref of an and mute. Oh, and it's if mode is and mute and.
Mhm. I think I like the idea of what's happening here, which is nicer than it right now.
Or I guess it's like else or if. This is really else if. Else if place contains a deref.
Of a box. Well, that.
I guess it doesn't really
Yeah,
matter.
you want.
It might not be a deref of a box because the mode might not match.
Mhm.
Truncate just before the deref, capture the pointer.
Mhm.
Let's call that, or like let place one equals place truncated just before the deref. Then we add move place one to C prime or something.
Mhm. Yeah, this is looking far simpler than.
And then it's
I'm trying
like
for this.
else add move place to C, I guess.
Mhm.
And so here now, if it's ref mute, I think these are the ones where we actually want to keep it just the way it is, I think. Right?
Mhm. I'm trying to, yes. There's, yeah.
This is probably ref star. I don't think it matters.
Mhm.
It's going to be an
Okay.
error
Give me
anyway.
1 second to. Let me think if there's an edge case to this. Like, I feel like the edge case to this will come only around when we are trying to return the closure out and anything else. But the point you made about if the root variable owns the data, or like the way you're accessing to the root variable ends up owning the data versus not. So
Right.
really define what you should do. So if you have a dereference of
There's one more
the
step
first two
too.
scenarios, then there's the unsafe and all those situations.
Okay, yeah, let's come back to that in a second. You're right, though. Let's add that to the XXX unsafe. So I think the other thing is, if it's a ref closure, we have a similar bit of logic to this that says if mode is move and place contains a deref,
Then truncate.
and you're right about the unsafe. I think that comes in. I think that's just here, and I think it
That's
like
unsafe
avoid.
happens at the very end. Is like, yeah, it's
Right.
okay, or that works.
I think it kind of doesn't matter where it happens, just it happens somewhere.
Yeah.
Sort of like,
Uh,
I'm just gonna write this the same
it's
way.
situational. It's just a little situational because you want to make sure one of them applies in the scenario of, I don't remember, one of them applies to only borrows, which is the taking a reference of a wrapper pack field in a wrapper pack struct.
I see. Okay. So that might want it to come later because.
No, that's the first thing that happens the moment we see we are borrowing something and what we're borrowing is of a wrapper pack struct. The reason we do that early on is so that because it is possible that someone moves the same data later on and then does and we decided that we wanted to avoid that. Like if you look at the bottom of the file, I'll write something which is something like print a dot back dot x and then the move. So in this we had talked about what we had discussed was not capture pack.x by move, rather capture pack by ref or by move in this. Like that would be the end result, but this would have been what you capture is.
So let's go through. Right. So we've got some examples now. Okay. I think we don't want to capture. Because we want it to be unsafe. If we moved out of pack.x, it would actually be correct,
That's
right?
safe to do. Yes, but the access to pack dot. Yes, but what we decided was we would do this, which is pack ref or pack dot
Yeah.
x.
I'm trying to remember our
Move.
reasoning. I think it makes sense, but I think the reasoning was like,
I think it was just for consistency.
it was more predictable. Adding in the move sort of
Yeah.
changed the behavior. Yeah, okay. So why? So key point here. This is an example of, this is like, I don't know.
Ref into unpacked.
It's called packed field ref and move. When you have a closure that both references a packed field, which is unsafe, and moves from it, which is safe, we capture
The
the,
truncated.
yeah, the entire struct rather than just moving the field. This is to aid in predictability so that removing the move doesn't make the closure become unsafe. This is really like, right?
Yeah, it was supposed to be a print line, but yes, that's, I think, just easier
Yeah,
to look
yeah,
at. Yeah.
it's easier to see it that way. So how does that play
Mhm.
out? That's why we have to do this early, I think.
Yes, this was the reason we did it early. Otherwise, we lose context about this.
Yeah, okay. And then I think that comes out correctly from this algorithm as we wrote it. Let's look at this example. Box mute, I don't know, whatever. So here, the C or the closure mode is move, obviously. The set is going to be just one member, really, which is
Mhm.
mute ref or ref mute, however I called it. This guy. And we're gonna
Mhm.
pass that through the first round. I wonder how, or I don't know. I don't really know how order sensitive these things are. I wonder if you can just put them all in one big bag. But anyway, we're gonna do C1 is like,
Yeah, that's kind of as well, but
this is gonna change
like,
it a bit. We go to this rule, so we keep it the same. So basically, we're
Mhm.
just gonna keep it exactly the same. That's the output.
Yes.
Output is the
C
same.
prime equals C.
Yeah,
Yeah,
exactly.
like on the surface, this looks so much simpler than what our implementation is, just based on like, I know where like the different handling of move and stuff happens.
Yeah. So the
And
question is, why is the
it's,
implementation like more complex than this?
I mean, it could just be that I didn't realize this could be this simple. It is. I think I know why this is. Okay, so I know why our implementation is a little different, just because if we think about this, this has three sort of. Okay, so this has three sort of passes. One is the collection phase, one is the apply the rules phase, and the third is minimization. And I think what we had initially talked about while we were doing was like we can apply the rules on the fly
Yeah.
as we see the data. And I think over time, with all the different exceptions we found, it just
Right.
became more of a just mismanaged sort of situation. So
Yeah.
might be a good time just to rewrite this.
So I think we could do this in two passes for sure, right? Which is we could say cleanup and truncation, which is basically generate C prime by mapping each mode. And we start with this, say unsafe checks.
Mhm.
Oh, well, I don't really want to add it right away. Stupid mathematical.
Yeah, I think unsafe checks
You,
right now happen at the pretty near the end.
right, but what I'm proposing is, I think in the code itself, we sort of have this structure, right? We have the first pass that like does the expression use visitor or whatever and builds up.
Mhm.
I don't think we should do any of this logic in the expression use visitor delegate. Like I would rather
I
generate a
guess.
simple list of where it, like it says here, exactly what it accesses. No
Yeah.
funny business. And
So.
then do this. Then we just do one iteration down
Mhm.
through, we just do a map where we truncate things and we get a new set.
Mhm.
And then we do a
Yeah. Yeah. It
and then we
also is
do the
because.
minimization, right?
Mhm.
Which is the
Also,
pairwise
like the
comparison.
reason this was, yeah. So the reason also we have this a little bit of weirdness is because it's sort of like I think what I inherited from the previous like 2018 version of this code, which was move closures would have certain degree of just like things like the initialization for move closures happened early on than later.
Yeah.
So I try to kind of keep the same situation where whenever we initialize for something, we would initialize using
Yep.
best. Like we would account for move closures early on. And yeah, I think this can be rewritten and
I think I think that
um,
structure just is not very good.
yeah, it's not
Uh,
feasible anymore. It's just,
yeah. So here's my, I think this is the way I want to formulate it. 3 helper
Mhm.
functions.
Wait, a move from should account for. Oh, move X from is in case of move closure. I see.
Yeah. And then hold on, I'm gonna do this, but now, because now we're gonna do the map, it's gonna say like, you know, mode 1, place 1 equals unsafe check mode place. If this is a ref closure, add
Mhm.
ref X form mode 1, place 1
Yep.
to C prime, else move X form.
Trying to remember or like think if this has something also to do with the fact that um, how you would handle different modes just coming in. I don't think that has anything really to do with it. Yeah, I think they should be fine.
I think this will work.
Yeah.
And then minimization.
Yes. And that's just, yeah, minimization is just a complete separate. Yeah.
What this does is
Yeah.
basically the logic here is we truncate accessed paths. We ensure unsafe accesses occur within the closure.
Mhm.
That's the idea. And here
Yeah.
closure takes ownership of data if
Only if the
accessed data is owned by the variable used to access it,
yeah.
closure
Yeah.
takes ownership, but only of the data on the stack frame
Mhm.
of closure creator.
Mhm.
And then else closure borrows data. And it's notably you can't take ownership of data you don't own anyway. That's a read.
Mhm.
Like if you move out from something
Mhm.
that's in a reference, you'll get an error anyway, so it's fine.
That makes sense.
Actually, what the closure does, like, just thinking.
Well,
Okay.
I think this is missing one point which says, like if it is possible that you're trying to move data out of a reference, but the closure doesn't still own the data, so you truncate to the pointer. And I don't think these two lines express that, unless I'm.
Well, yeah, it's you're right that if you try to move out from data you don't own, we will truncate it.
We trunk
You'll get an error
to
later
the
on.
pointer.
Right? Like the borrow checker is going to
That
give
too.
you an error at some point,
That too.
but yeah.
Yeah. I realized that while writing the reference that I'm pretty sure I'm handling that case, which is just actually just an error.
Right.
So yeah, there's a
So
couple
that's
things
kind of
that
if accessed. So basically we're saying if taking ownership of data or borrowing data owned by the variable used to access it, closure takes ownership of, yeah, like this. It's kind of complicated, but that's what it is.
wait, so do we really care about situations where we see a move out of a, I suppose that is still, so we see, okay. So there's a situation where we might have to do a copy instead of a move, right? So we need to probably handle that.
But copies are treated as
By
a ref.
values.
No. If you
Oh,
take,
right.
if
We
you
treat them as
access
a,
copy data, it's a ref. So that will be a ref.
right. Yeah. Yeah, suppose the new version doesn't really care about data being copied anymore. Like it just fits into the model.
Yeah, I think it
Because
just
earlier
fits.
they would be set. Yeah.
Yeah, so this would be like this one's a little bit complicated. It's basically take ownership if closure moves the data out or the data being accessed is owned. It's I kind of just to keep this simpler, if data being accessed is owned by the variable used to access it. I don't want to cover the error case because like I'll put it in parentheses. When taking ownership, only move data from enclosing stack frame, or like only capture data found on the stack.
If I write, so I think this may or may not be important, but so when you see a let x equals y, let's say in a closure, and y is a copy type, I think x per use visitor tells you it's a by value use.
I don't think so. It might be right though. I don't really know.
I'm trying to remember. I'm trying to figure out why certain pieces of the previous code existed.
Let's look. Because I thought, let's see, copy or move. Oh, you might be right. It might do a consume with a mode copy.
Yeah.
Okay.
So which would
Okay.
mean that we
Okay.
would see. So now if we have a
Well,
scenario where we have a reference.y, like let x
I think.
equals some reference.x, then in that scenario, we cannot actually move or take a reference to ref.x because we might like, okay, let me write this out. It might be easier if I write this out.
But I think
So
we treat
bottom of the
that.
file.
I think we should treat that as a ref. And I think that the code does that somewhere else.
Let me write this out 1 second and see what's like. I don't have a complete picture in my head, but I want to write it out so that I get an idea of what's happening. So we have, let's see, equals this guy. Something like this, and then it returns C. So what the closure will see here is x.x is a by value use. And let's just say this is a point. And point is defined as xi32, yi32. So we have this, right? Now we see that x.x is a by value. Based on the algorithm that is right now, we will see that it is a move of a deref. So it's not a ref mute. It's not. This is a move
Oh,
closure, which is not a ref.
we also
It's
forgot
not a
one more
ref.
thing. We forgot the optimization.
Yes. Oh, I suppose, yeah, I was going for optimization just being outside the borrow checking algorithm closure algorithm, but fair enough.
I think we should represent it. Uh, this is like capture ref or borrow or capture a reference and not data it owns or something. I don't know. I'm just gonna put this XXX for now, but I think this is the
Mhm.
last step, right?
Mhm.
Like we do that as a final pass.
Well, no, that is the first thing that happens because again, like what we discussed was we want to do this as the first thing as we see it, but can be the last thing as well.
Not
Yeah.
sure.
I don't think either or really matters.
It probably doesn't really matter. Yeah.
All right. So if we have, yeah, so we have this, and I think, yeah, we will end up capturing, if we apply the rules, after rules, we capture X by value, which is fine. I think. Yes, I think it's correct.
I'm trying to think what we actually want here. So
Yeah.
there's another example might be,
I think right now, though, it might do X dot X by value, which is also not wrong to do. Wait, that's the same thing.
So
1 second. I'm just running this to play around just to see what the current output out of this is. I have a feeling it might do.
I'm trying to think, what am I trying to prove with this example? I think if you, right, so
Yeah,
I think I would like these
this,
to work,
yes. Me too.
but this is a ref mute access. This is just gonna work because you're gonna get the ref mute and it's gonna see that it's a deref of X. Right.
Mhm.
But if you did, okay, so this is a better example, I guess. If you just look at this example. Now we have a
Mhm.
read from X and a read from Y.
Mhm.
And what could happen if we move X, we're gonna get a compilation error here because X can only be moved once because it's an ampersand mute.
Yes.
But I
What's
think
more?
what I would sort of, I guess, even more interesting would be like this one. Yeah. I think that this example ought to be like ampersand star. Let's rename this from X to P. Just so
Yeah, that was a bad choice of. Wait, so 12 is behaving exactly as what you wrote right now, like what you wrote right now. Yeah,
that's what you get
that's
today.
that's what I get today. Yes.
I
Yeah.
think, yeah, no, and I think that's, I don't quite know why that is, but let's look at one other piece of code, I guess. Where's the upvar code? Like,
Yeah, I know this because I remember handling copy type specifically and they move things. which can be handled later on without making the code complicated, but yeah, it's pretty short. I'm doing something
So,
on.
okay,
Can you share your screen for that? So I know which part you're talking about for the code.
I am sharing my screen.
Oh, never mind. I was looking at this. Sorry, my bad. Yes. Mhm.
So,
So let me explain what this is. So if you look at line 1357, that is where we see,
1357.
oh, this is a copy type and it's a deref of a, yeah. So that's a copy type. So there's a move closure. It's a copy type that we're moving and the deref is of a reference. So we just return as is. And if you look up the function called init capture info, I think, or init underscore capture kind, it would have initialized the place by a reference. So this has a, yeah, and right, so this is init capture kind. There's another function which is like line 1576 that gets called.
Okay.
So if you look over there, if it's a move closure and all the dereferences are of a reference, then we initialize it as a ref. So we take a reference to that.
Yeah. So, okay. What I'm just trying to figure out is if it's a move or if it's a copy, is that, should we just treat it like a ref all the time? I think maybe yes. I'm trying to
I
come up
think
with
so.
a scenario where it does the wrong thing. And I don't, like, I know that in, if you go to code today, like suppose I have,
You can just take the example we have, I suppose.
so if I just have this copy type here, right, and I try to return something that uses it, this is going to give me an error.
Yeah, you need a move closure there.
Right, and so the point being, we're treating it as if we borrowed it. Well, println isn't the best example because println actually does borrow it. But I think here we will also need a move closure unless I'm totally mistaken, which would be, yeah. So even though this is a copy, right, we treated it like a borrow. So I think we can just treat copies as refs. And that means in terms of our description up here, I actually change this to move and I would say note by value use of a copy type is considered ref. And I think that'll get us the right behavior. Because if it's a move closure, we're going to change that ref to a move.
So should we add a thing which basically, like before we start our, so there's a thing where the cleanup and truncation, I suppose, part where you have, maybe we should add that if it is a, like basically have a helper function from like completeness of the algorithm perspective, where your place.type is a copy type and mode is by value, it converts it to place.type and makes that into a ref so that the algorithm rest of
Sure,
it can proceed.
I changed, sure, that's not a bad idea. I had made this move, but if we make it, that's probably better. Okay, let's do that. This goes back to by value. And then we say, copy type. It's basically if mode equals by value and type of place is copy, ref place,
Mhm.
return else,
Yeah.
return mode place.
Place. Yeah, that makes sense.
So sure. And then we can just sort of throw this in there.
So,
And these places where we wrote move, we really meant by value.
mhm. Yeah,
Wait,
and that's just mode.
no, this actually meant mode. That's a subtle point. Or did it mean move? What did it mean? If a place
No,
contains,
that's a mode. That's mode. That's mode.
yeah, it's mode. Whereas here is actually by value.
That needs to be, yes.
And so
That
is
needs to be by value too.
this, and so is this, and then this is mode. Only it should be return. Okay.
Mhm. Yeah. Yeah, all of that needs to be returned.
Shit.
I like the simplicity. Yeah.
Yeah, I think we could actually implement it this way, right? This is not like wildly inefficient. It's perfectly reasonable.
Yeah, this is prettier in some sense.
I would, this, by the way, this is exactly what I think would be nice. It would be great to include in the reference.
I think we can just post it as is, honestly.
Basically just copy and
I
paste
mean,
this into the reference.
Yeah.
It was fine. It's good enough.
I think it's like concise. I like there isn't really any shorthand here. It's like well explained and less complicated than the specification I was thinking of writing.
Yeah, it's really easy to read too.
Yeah. Yeah, we had to write a specification for our project and it was far more complicated and weird.
All right, I'm feeling satisfied. I'm curious whether we should try to implement it and see if we encounter any weird behavior, but
I might implement it today and see how. Wait, I don't have anything else pending other than this, right? To fix.
I don't think
This
so.
should fix one of the bugs as well, which is the
only
box
other
one.
thing was the -C closure size flag working with 2021, which I don't really think we need, especially if we're gonna.
If we can close it, I don't mind closing it. Just like there aren't, and changing the other thing that you pointed out to stand it out is also just pretty easy. Because yeah,
especially if we're just going to use it for a crater run, then and not really request people to do it, which is kind of easier for us, honestly. Then then who cares?
Okay.
So okay.
Yeah.
As long as it doesn't like
So
totally die. What was this ref
it
up?
should not. Oh, we were about to write the optimization.
Oh, the optimization.
Right.
Yeah.
Yes.
So, optimization. Don't borrow the ref. Not data owned by ref. So here we say if this is like if mode is ref and place contains a deref of an ampersand or something. I'll let you.
We don't even need the mode as ref. We can, the mode is move. We can still by value. We can still do it, right?
That's true. Yeah, that's true.
Yeah. I'll do this once the current reference PR is merged, then I'll just copy paste this as well.
All right. Well, great. I
Yeah.
have to run to another meeting. Thanks, y'all. I'll post the
All
recording.
right, thank you so much.
Yeah. See ya.
Yeah, I will post this link in the. All right, see ya.